Okay, I've got up here on the board the graph of tangent with a restricted domain. So we said the inverse of this was arctan, and my goal is to figure out what the graph of arctan looks like. And the basic idea is that what we're doing when we create an inverse function, remember, is we're just switching the roles of x and y. So what I want you to do is take out a piece of paper, and it has to be a piece of paper that's physically detached from everything else. So it can't be connected to a notebook. You have to be able to wave it in the air. This is not the white flag of surrender that this math is too hard and you give up. This is just a technique for graphing inverse functions. So on that piece of paper that you can physically move around in a way that I can't move this whiteboard, what I want you to do is draw a pair of axes. And of course, the horizontal axis is the x-axis and the vertical axis is the y-axis. But as we move things around, I don't want to lose track of that. So I'm just going to label, this is the positive y-axis here. This is, sorry, positive x-axis. This is the positive y-axis. Over here, we would have the negative x-axis. And here we would have the negative y-axis. So I've done that here. I've taken this piece of paper and I've labeled it like so. Now what I want to do is I want to switch the roles of x and y. So I want this vertical axis to become horizontal, and I want the horizontal axis to become vertical. So I'm going to take my piece of paper and I'm going to rotate it 90 degrees to the right. Okay, rotate 90 degrees to the right. Now, I'm not sure how well this is going to show up, so I'll show you what it should look like now. The y-axis basically just lay down to take a nap. So we've got the positive y-axis here, the negative y-axis here, the negative x-axis has come up here, and the positive y-axis is down here. So we have switched the roles of x and y. What used to be y is now on the horizontal axis. What used to be x is now on the vertical axis. But we haven't really preserved the orientation, because I'm used to positive is to the right. We still have that. But I'm also used to positive is up. And now up is the negative direction. I'm not crazy about that. So what I'm going to do is I'm going to take my piece of paper and I'm going to flip it top to bottom. Now when I do that, I'm going to be looking at the back side of the piece of paper. The writing is on this side over here. I'm looking at the back of the piece of paper. Now because I wrote pretty dark with a whiteboard marker on a piece of paper, I can sort of read through it just a little bit. You might have to, if you didn't write with a whiteboard marker on your piece of paper, you might have to kind of hold it up to the light. But you should, paper's thin enough, you should be able to sort of read through it. And if you flip it top to bottom, you should get something that looks like this. You'll have positive y here and negative y here still. But now you'll have positive, sorry, I wrote that wrong. That should have said positive x here. And now when I flipped it, that positive x came up to here, and that negative x came down to here. So, rotating 90 degrees to the right, flipping top to bottom, successfully reverses the role of x and y, preserving the orientation that the positive directions are to the right and up. So now, go back to the original side of the piece of paper that you wrote on. Draw this function. Draw tangent with a restricted domain so that x is only taking on values between negative pi over 2. Take your piece of paper, rotate it 90 degrees to the right, flip it top to bottom. Hold it up to the light and try to read what you've got through the piece of paper, and then before you forget what it looks like, put it down and copy down what you see. And what you should see is something that looks like this, and this is the graph of y equals arctan of x. Notice these vertical asymptotes, when we switch the role of x and y, vertical becomes horizontal. I now have a horizontal asymptote at negative pi over 2 and at positive pi over 2. Okay? And on the back side of the piece of paper, this was labeled as the y-axis. That was for the original function. The y-axis for that graph does become the x-axis for this graph. So if I label it for the inverse function, I can see that y is arctan, y is my angles. It's on the y-axis that I've got my pi over 2 and my negative pi over 2. Kind of neat, okay? And that's a nifty way of graphing inverse functions, just turning and flipping. This is a function that you're going to want to be familiar with, because one of the things you're going to be doing as you move on to pre-calculus and then calculus is we often talk about what's called the end behavior of the graphs. What happens as x goes off to infinity, as I plug in bigger and bigger and bigger things? And sometimes when you plug in bigger and bigger things, you just get something bigger and bigger and bigger and bigger. Here, we're getting closer and closer and closer to pi over 2 as x goes off to infinity. So that end behavior is captured really nicely by looking at the graph of this function. All right.